Welcome back. This is Subramaniam Shankaran joining you for CISSP lecture in order for you to master it. Now, coming on to the integrity protection, the integrity need not be a man-in-the-middle attack. There will also be an unintentional integrity issue. Okay, could be tampering of the data because if you have been tying your network cable and the power cable together, there's something which is also an audit point in ISMS audit. Okay, the prudent auditor will get onto the data center. He'll ask you to open the rack and see if the network cable and the power cable are tied together. Because if there is a fluctuation in the power supply on the power cable, the electromagnetic interference will also impact the data that is actually flowing through the network cable. So that could also be a reason for an integrity issue. Attenuation of the media is the resistance of a media. Usually, the communication cable, you can use it only for a certain meter as recommended by the standard. If it's going to be beyond that, then you will see there's a noise is getting added up to the actual signal, and at the end, it might not be the clear signal, but the noise is also getting mixed up. So, in turn, the data will get tampered, and you might not get the right data, okay, at the end of the channel. So ensure that they're going to use the cables, or even it's going to be a wireless medium, okay. There's a certain distance until which it can work to the perfection. So you ensure that you use it only within the advisable limit. Physical damage, yeah, in fact, personally I had faced the physical damage leading to an availability issue rather than integrity. So the cables are getting through your window or a door, and you close the window or a door, and you don't get the signal, the internet connectivity on your system. So if you're on a wired media, so that's also one of the things that you have to look out for. Ensure that the cables have an unrestricted pass-through until your system. Intruder, obviously, this is something that we are all concerned about, the man in the middle. And if you're going to send a data, and if there's an intruder who is going to modify the data, that could be the modification is an integrity issue anyway. Yeah, so we also discuss about this. For example, you can also demonstrate this using what is intercepting proxies like Burp Suite, in which you can intercept the traffic between the source and the internet, and you can modify the data. In fact, there is a demonstration visible, which is being done using the Altero Mutual demo test file, which has been owned by IBM for the demonstration purpose. So intruder is a man in the middle, and we actually saw the different types of man in the middle attack in the last video. So getting on to the next one, it's called the one-way hash function. So why do we call this a one-way hash? Because the encryption is a two-way function. For example, I can encrypt, I can decrypt it, but in the hash value, I actually cannot find out from the hash value what the input text is. Let me show you a demo. Script tool. I am CISSP certified. Okay, so I'm going to calculate the individual procedure. I calculate the MD5, a popular one. Okay, this is what is the hash value. And the input is I'm CISSP certified. Okay, we don't call this as a plain text because there's nothing called as a plain text and ciphertext when it comes to hashing. Okay, now what I'm going to do is I'm going to copy this plain text. Okay, let me introduce a space after that. Let's see. Okay, if you see here, okay, it has come to a very great extent. Okay. Individual procedure, hashing algorithm, MD5. Come on. Yeah, this is hash value. If you actually look at this hash value, it's totally different. That is number one. Number two is from this hash value, it is impossible for me to calculate what my input is. Now, even if I'm going to send the complete Sean Harris all-in-one CISSP preparation book, or Cybex or Eric Conrad, whatever it is. If you want even all the books together, it's going to, and if you want to calculate the MD5 value, it's going to still give me some value, the length of this one. Okay, we will look at what the length of the MD5 hash value during the course of this particular video. Now, what I mean to say is, the hashing algorithms, this MD5, okay, the hashing algorithm will give you an output, and from the output, it is impossible to calculate what the input was. So the hashing algorithms they're all actually called as a one-way hash function. One-way hash. And you should be calculating the hash value across the complete message, but not a part of it. Why? Because I am CISSP certified. Okay. So again, I'm calculating the individual procedure hash MD5. This is for I am CISSP certified. Okay, certified. Now, if I'm going to add a not, and still if I'm going to calculate the hash value only excluding the not, okay, for the complete message excluding the not, the hash value does not change. Okay, so we need to complete the hash value including the not. I need not actually highlight that, okay. This is for I am CISSP certified not. Having said that, if I'm going to calculate only for CISSP, I am CISSP certified, it will be the same as the previous value. Okay. Now, what I'm actually going to do is I'm going to remove this not. Okay. I'm going to introduce a space. Excuse me. I'm going to introduce a space. Okay. If you look at the hash value, I have introduced a space next to D. Okay. If you look at the hash value, it's totally different. Okay? There's no correlation between I'm CISSP certified and I'm CISSP certified with a space next to D. Now, this principle is actually called, this property is called as an avalanche effect. Okay, for a small change in the input, there's going to be a drastic change in the output. Okay, drastic change in the output. Now, variable length, okay, and the fixed length output is what the hashing algorithm is going to produce. That's what we saw with the I am CISSP certified and I am CISSP certified multiple times, maybe 100, 200, whatever it is. Okay, it's a one-way hash. You can calculate the hash value from the input, but you cannot actually calculate the input from the hash value. With the demonstration that we have done, now we understand what it is. Okay, so hashing is an integrity prediction, and it is also called as a message digest. Just to add up as a title to the very popular MD series of hashing algorithms from Brown Rivest. Yeah, so we already saw as a demonstration in the previous video that your the message plus the symmetry key, okay, used between the sender and the receiver, okay, can be used together in the hashing algorithm as input to the hashing algorithm to produce what is called as a message authentication code. Okay, this could be a symmetry key, or this could also be a session key. Session key is anyway a symmetry key, is used only for that particular session, whatever it is. Okay, we call the output as a message authentication code, but not just a hash. Okay. So with this adding in symmetry key, we are going to challenge the man-in-the-middle attack. Okay. The characteristics of the hashing algorithm must be computed over the complete message. We saw as a demonstration that I am CISSP certified and I am CISSP certified not. Okay, should be a one-way, so we cannot actually calculate. It should be it should be impossible to calculate what the input is from the message digest or the hash value. Should be resistant to the birthday attack, and we will discuss about the birthday attack in the next video. And given the hashing algorithm and the input message, it should be impossible to calculate the same hash value for a different message. If this is possible, this condition is actually called as a collision. There are a few algorithms that are prone to the collision attack that we will anyway have a look at. Hashing establishes this core principle: data integrity, data or file integrity, secure authentication. Okay, in fact, on the real-time scenario, the time-stamped hash value of the password is what travels from your system to the authentication server to ensure that you are authenticated. Okay, because the password does not travel on the network of the plain text, it should not. Otherwise, it's prone to the man-in-the-middle attack. The users with a simple Wireshark will be in a position to tamper stuff the traffic and get to know what the password is. Even if you're going to convert this to a hash value without a timestamp, I can do what is called a replay attack because the password is not going to change anyway. So if you're going to have a timestamp and your password to calculate the hash value for authentication purpose, this is a very secured way of establishing the authentication between the client and the server. Yeah, so it facilitates secure authentication. So you can organize the content of the file in a way it increases efficiency in case the organization or the file is tampered. Okay, so your hash value is going to get modified anyway. Okay, so you can store your password in a secure way in the database. For example, if you look at the etc shadow with the Linux system, you can see the hash value of the password is actually stored. We can have a demonstration with John Thirupa to do an unshadow and to reveal the password. But when it reveals the password, it clearly says that it has been secured with SHA-1 or SHA-2, whatever it is. Okay, if somebody is going to look at the file directly, they might not get to know what the password is unless otherwise there's a collision. Because in a dictionary, you can have what is called the rainbow table. Okay, you can have dictionary of password in the first column and have MD5, MD6, SHA-1, SHA-2 equivalent to the passwords in the column 2, 3, and 4. If somebody is going to use a very common password, which is a part of the SIG list, okay, Daniel Meissler's SIG list, and we can easily break it with a collision attack. Okay, otherwise it's impossible to calculate your input through the hash values. So it's used for storing the password on the databases. Avalanche effect is what we had seen now. Okay, a small change in the input should be in a push, should be giving you a drastic change in the output. Collision resistant, it should be given the input and the hash value. It should be impossible to calculate for a different input the same hash value for using the same algorithm. Determination is to use the complete input to determine the hash value. It should be Oneway. It's irreversible. Ideally, none of the hashing algorithms are vulnerable to the reversing attack. No. Okay, collision, yeah, but not reversal. Okay, do you think that the entire Sean Harris book can be reconstructed from the simple hash value of using MD5? No, it cannot be. Okay, but we can do a collision attack. I subject the Sean Harris book to the MD5 algorithm. You subject the Sean Harris book to the MD5 algorithm. Output is same. Okay, provided the digitization and all this, okay, the quality of the PDF conversion, all these things. Okay, but still, what I mean to say is, it's irreversible computation. You cannot actually calculate the input. Few algorithms to have a look at. There is a predecessor MD, okay, and then MD2, etc. But MD5 is most popular. Okay, even now I see MD5 algorithms being used in spite of being susceptible to what is called as a collision attack. Okay, so MD5 has been susceptible to collision attack. Same goes with an SHA algorithm as well that we'll have a look at. But yeah, so MD5 is still popular. 128-bit digest. Messages are processed in 512-bit blocks, like how the encryption was on 64-bit blocks. The MD5 works on 512-bit block. 4 rounds of transformation until the output is actually produced. The output is represented as a 32-bit or 30-digit hexadecimal. MD6, very large input message is something, if the input is very large, we can start using MD6, okay? So message blocks up to 512 bytes, okay, it's variable. Produces a variable and digest up to 512 bits. So when you invoke the algorithm for calculating the hash value, you have to specify to what is the length of the message block, what is the length of the digest that you actually want. Okay, that is an advantage of the MD5 as compared to the advantage of MD6 as compared to MD5. Okay, so SHA-1 published in 1995, fixed length output 160-bit message digest. Okay, so Usually you will get confused on what would be the length of the message digest, because we always think about 64, 128, 192, 256, etc. But this 160-bit message digest. Okay, it also works on 512-bit blocks and adds a padding to the message if necessary. If the message is only 500-bit, okay, it adds 12-bit padding and then it actually processes that. Algorithm is actually not very stable and it was susceptible to few attacks. So the SHA-1 is something which people don't use it very often. Okay, so they go to SHA-2. SHA-2 has got two variations, SHA-224 and 256. Okay, well, the digest length of 224 and 256 respectively. 224 is just a truncated version of SHA-256. The same goes with SHA-3 also. Okay, 2015 is what we had, the SHA-3. So SHA-3, 384, SHA-3, 512, it falls on the same family. And again, SHA-384 is a truncated variation of SHA-512. So this is on your hashing. And there's one more algorithm, which is also something which I would like to discuss about, is a Tiger developed by Ross Anderson. Ross Anderson is an author of an excellent book called Security Engineering. I was really happy because in 2015, when CISSP called the domain as Security Engineering, okay, because it matches with the title of the very popular book from Ross Anderson. Excellent book, not for CISSP, but for your information security carriers. The wealth of information is available on that particular book. This is something which I would recommend any information security professional to buy that. Okay, it works on 64-bit system, produces 192-bit hash value. The design is not based on SHA and the MD. Okay, so hence it is not susceptible to the similar attacks that the SHA is prone to and MD is actually prone to. Okay, so this is on your hashing. In the next video, we'll discuss about the digital signatures with respect to the algorithm, because in the last video on the scenario 3, we already discussed about the digital signatures. Thank you very much for watching this video. Stay connected by subscribing to my channel. More videos to come on CISSP, more videos to come towards your penetration testing, and more tips and tutorials to come on the same channel. Stay connected and happy learning. Cheers then. Bye-bye.